In this video, we will find intervals of increasing and decreasing, concave up and concave down for this function. If you appreciate the content, please give it a like. Before we get started, a quick word about abbreviations. In my other videos, you will often see me use these abbreviations for positive, negative, increasing, decreasing, concave up, concave down, and because. I accept these abbreviations in my class, but to be clear, you are taking a risk whenever you use abbreviations on the AP exam. That's because it's up to the AP grader whether or not they're going to accept these abbreviations. Most AP graders will accept these in AP Calculus. However, not all of them. So if you want to be 100% sure of getting credit, don't use abbreviations on the AP exam. On the other hand, if you're pressed for time, it might be worth the risk. The first step is to find an expression for y prime. Let's go term by term. The derivative of x squared is 2x. I'm thinking of 16 over x squared as 16 times x to the negative 2 power. So using the power rule, the derivative is negative 32 x to the negative 3 power. The next step is to find where y prime is equal to 0 and where y prime is undefined. However, in order to do that, we really want to rewrite this as a fraction. So we can set the numerator equal to 0 and the denominator equal to 0. So let's drop this x to the negative 3 power back down to the denominator. To combine these into a single fraction, we need like denominators. So let's multiply by x to the third power over x to the third power. Now that we have like denominators, we can combine these into one fraction over the common denominator. Now we can find the critical values of y, where y prime is equal to 0 and where y prime is undefined. A fraction will equal 0 when the numerator is equal to 0. So y prime will equal 0 when 2x to the fourth power minus 32 is equal to 0. Adding 32 to both sides, we have 2x to the fourth power is equal to 32. Dividing both sides by 2, that's x to the fourth power is equal to 16. Taking the fourth root of both sides, that's x is equal to plus or minus 2. Actually, I'm going to go ahead and write these separately so you can clearly see we are looking at two different critical values, x equals negative 2 and x equals positive 2. Now, a fraction will be undefined where the denominator is equal to 0. Taking the cube root of both sides, we get x is equal to 0. So now we have three critical values with which to make a sign chart. Actually, before I make the sign chart, I'm going to go back and factor the numerator of y prime. And I could have used this to find these critical values as well. I notice that we have a common factor of 2. So if we factor out the 2, that leaves behind x to the fourth power minus 16. But this is the difference of two squares. X to the fourth power minus 16 will factor as x squared plus 4 times x squared minus 4. The first factor cannot factor any further. You cannot factor the sum of two squares. However, the second factor is again the difference of two squares. So this can be factored further. So this is the fully factored form of y prime. Notice we could have used this to find the critical values where y prime is equal to 0 because looking at the numerator, we can see that we get a critical value of negative 2 from the x plus 2, positive 2 by setting the x minus 2 equal to 0, and x squared plus 4 has no solutions if you were to set this equal to 0. X squared plus 4 is never equal to 0 because x squared is always going to be positive, well 0 at the very least, and then you're adding 4, so you're never going to get 0. So that's why there's no critical values coming from that. Anyway, I'm going to use this form to make my sign chart. Set up your sign chart like this, with your critical values in order from least to greatest across the top, and a row for each factor. Make sure you have labeled your sign chart as y prime. I factored this out because I find it easier to follow what's going on the sign chart if I have a row for each small part of y prime, but it's up to you how many rows you really want to make. We need to decide whether these factors are positive or negative in each interval. 2 is positive everywhere. It's just always positive 2. X squared plus 4 is always positive, as I discussed earlier. X squared cannot be less than 0. And then we're adding 4 to it. So this is always going to be at least 4. Positive 4. X plus 2 is equal to 0 at negative 2. So this is the only place where this factor might change signs. It's going to be negative for values of x less than negative 2, and positive for values of x greater than negative 2. X minus 2 is equal to 0 at x equals positive 2. It's going to be negative for values of x less than 2, and positive for values of x greater than 2. Cubing something does not affect whether it's positive or negative. X to the third power is equal to 0 when x is 0. It's going to be negative for values of x less than 0 and positive for values of x greater than 0. The overall sign of y prime depends on the number of negatives in each column. An odd number of negatives means y prime will be negative. An even number of negatives means y prime will be positive. So y prime will be negative in this interval and positive in the last interval. Make sure you have memorized the graphical relationships between f, f prime, and f double prime. You should be able to draw this chart from memory on a piece of scratch paper or in the margin for your next test or quiz. What matters now is that f will be increasing wherever f prime is positive, and f will be decreasing wherever f prime is negative. So y will be increasing from negative 2 to 0 and from 2 to infinity, and y will be decreasing from negative infinity to negative 2 and from 0 to 2. We say y is increasing on the interval from negative 2 to 0 and from 2 to infinity because y prime is positive. Y is decreasing on the interval from negative infinity to negative 2 and from 0 to 2 because y prime is negative. In order to find intervals of concavity, we need y double prime, the derivative of y prime. Let's take the derivative based on this form. The derivative of 2x is 2, and using the power rule, let's see. Negative 3 times negative 32 is positive 96. So we have 96x to the negative 4 power. Let's form this into a fraction like we did for y prime. So dropping the x to the negative 4th power down to the denominator gives us this. We will make like denominators by multiplying by x to the 4th power over x to the 4th power. So putting these together, we have 2x to the 4th power plus 96 over x to the 4th power. These do not cancel out. You cannot cancel out things that are connected by addition or subtraction. Now we need to find where y double prime is equal to 0 and where y double prime is undefined. A fraction will equal 0 when the numerator is equal to 0. So y double prime will equal 0 when 2x to the 4th power plus 96 is equal to 0. Hopefully you can tell at a glance that this equation has no solution. 2x to the 4th power plus 96 can never equal 0. Because we are raising x to an even power, negatives will turn positive. So this term can never be less than 0. It can never be negative. So if you have 0 or a positive number and then you add 96, that's going to be a positive number, never 0. The smallest this expression could ever be would be 96. If you didn't realize that and you sort of went ahead with the problem, you would subtract 96 from both sides. So you would have 2x to the fourth power is equal to negative 96. And then when you divide both sides by 2, you get x to the fourth power equals negative 48. Hopefully now you see that there is no solution. If you raise anything to an even power, you're going to get a positive number, never a negative. So we have no critical values so far. But we need to find where y double prime is undefined. A fraction will be undefined where the denominator is equal to 0. X to the fourth power will equal 0 when x is equal to 0. Or you can think of it as taking the fourth root of both sides. So we do have this one critical value with which to make a sign chart. Be sure to label your sign chart as y double prime. That's an important part of your work. We need to decide whether each one of these factors is positive or negative in each interval. As we discussed earlier, this first factor is always positive. It will never be less than 96. So it'll be positive in both intervals. And here we have x raised to an even power. So that will be positive in both intervals as well. Obviously, that means that y double prime is positive in both of these intervals. Y will be concave up wherever y double prime is positive, and y will be concave down wherever y double prime is negative. Y will be concave up from negative infinity to 0 and from 0 to infinity. Be careful. It looks like we have two consecutive positive intervals, so it's tempting to say that y will be concave up from negative infinity to positive infinity. But y double prime, and in fact y itself, is undefined at 0, so we cannot include 0 in the interval, so you do have to split it up. Y is never concave down. We say y is concave up on the interval from negative infinity to 0 and from 0 to infinity because y double prime is positive. Y is never concave down because y double prime is never negative. Y will have a point of inflection wherever y double prime changes signs. However, y double prime does not change signs. And actually, we should be careful here. Even if y double prime did change signs right here, it still wouldn't be a point of inflection because our only critical value here is a place where y double prime is undefined. And an undefined value cannot be a point of inflection. We say y has no points of inflection because y double prime never changes signs. Now it's time to sketch a graph of y based on the information above. Let's begin by separating the graph into intervals based on the critical values we found along the way, -2, 0, and +2. Now let's label y as increasing or decreasing in every interval. We found that y is increasing on these intervals and decreasing on these intervals. Now let's label y as concave up or concave down in every interval. Of course, we found that y is concave up in every interval. In addition to this information, let's identify any places where y has a horizontal tangent line. Y has a horizontal tangent line wherever y prime is equal to 0. We found that y prime was equal to 0 at x equals -2 and x equals +2. Let's put a little horizontal mark at -2 and +2 to remind us to sketch a horizontal tangent line when we approach these values. So here we go. In the first interval, y needs to be decreasing, concave up, and form a horizontal tangent line at the end of the interval. So here we go. Decreasing, concave up, and rounding out at a horizontal tangent line. In the next interval, y needs to be increasing and concave up. Now, y is undefined right here. This is probably a vertical asymptote. So I'm just going to do increasing and concave up and avoid that thing. Similarly, in the next interval, we need y to be decreasing and concave up and round out at a horizontal tangent line. So here we go, decreasing, concave up, horizontal tangent line. And in the final interval, y is increasing and concave up. So increasing, concave up, and that's it. This is an asymptote. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.